Thank you so much, Dr. Zoka. So these are my disclosures, nothing except that I'm not a surgeon. And two, I'm really not an expert in this. I am really learning as we go. And three, actually, no, that is absolutely true. There's just so much. And three, when Dr. Zoka asked me to present, we were like, oh, there are months to go. Maybe we'll finish this project. But we haven't, so I really don't have hard data to give you. But we'll go through the whole process of LC and how to actually perform or do carbon footprinting of colonoscopy. And we can probably even talk about why we couldn't finish yet. So what is carbon footprint? It is a total amount of greenhouse gases that are generated by a person, product, event, anything, coffee cup, anything over here, that generates carbon footprint. And what are greenhouse gases? Any gas that accumulates in the atmosphere absorbs and re-emits heat, thereby having a potential for global warming. These are just kind of just basic definitions, I guess. But why carbon footprint of colonoscopy? A, why not? Two, it is the second overall highest waste generator in a hospital. And number three, hazardous waste generator in healthcare overall. And we do more than 13 million colonoscopies in this country. And this was in 2019. I'm sure it's increased. Well, actually, maybe not increased due to the pandemic. Why? And not just the waste. It's very, very resource intense. We use so many single-use consumables, including scope buttons. If I'm sure a lot of you have done colonoscopies. Scope buttons are disposable, snares, clips, forceps. I mean, it's just a plethora of disposable items and patient travel, etc. Now, what are the implications of calculating carbon footprint of anything, let alone colonoscopy? Anything in healthcare or anything in general, we can identify carbon hotspots. Which instrument is really, really carbon intense, or which process, and how we can improve that, right? And we can design ways to reduce that carbon footprint and help mitigate healthcare carbon footprint, like some speakers mentioned. Healthcare does have a very, very significant carbon footprint, especially in the US, contributes 27% to the global healthcare carbon footprint. Now, to understand carbon footprint, we need to understand scopes of emissions. So there are different scopes of emissions. These are different categories of emissions that are generated by a product or a process. Scope 1 is direct emissions related to the product. For example, energy related to plugging in a scope and how much electricity is consumed, right? What is scope 2? The indirect, but related to the process, like, for example, the facility, mostly related to electricity, heating and cooling of the facility or the room, for example. And scope 3 is all the other indirect emissions, especially supply chain. So, just a representation. Now, the problem with healthcare is 70% of healthcare emissions come from supply chain. Medical devices and supplies, big carbon hotspot, and they come under scope 3. And that's the biggest problem in calculating the carbon footprint of anything in healthcare. Now, to account for all of these types of emissions, and I didn't mention scope 4, which is not usually mentioned, but it's just omitted or saved emissions, or what's called scope 4. For example, compare one to the other, how much have we saved? Now, to account for all of these emissions, life cycle assessment is the best way to calculate a carbon footprint. And what is it? It's a method that considers all of the stages of a product, starting from what resources are used, what natural resources, for example, trees in paper, and then everything that goes into manufacture, everything that goes into transport, its use, and its disposal. Okay, so it considers every part of the life cycle of any product or process. Now, there are two types, or you can do it two ways, cradle to grave and cradle to gate. Cradle to gate is when you consider the life cycle from the initiation cradle to the use of the product. For example, if you're taking the screen, just the use over here, and we end the emission calculation there. But if we want to account for how you dispose this and what happens to it afterwards, then it's a cradle to grave calculation. Now, for colonoscopy, cradle to grave makes a lot of sense because it has colonoscopy creates so much waste. Anything from 1.5 to about 3 kilogram per procedure. So that makes more sense. Now, there are different types of LCA. We talked about financial modeling, but there's also process modeling, which is actually really useful in healthcare carbon footprint calculation, because then you can account for everything, all of the different emissions, scopes of emissions. Now, we probably should use both because nothing is perfect, and whatever process-based modeling cannot complete, you can use the financial modeling for that, especially for medications and chemicals, which is very hard to build in in the process-based models. Now, how do you do it? You go through steps. The first step is goal and scope definition, which is you need to have a question, a clear hypothesis, and then you need to define a functional unit and then define or determine the boundaries of your study. What I mean by it is this is a very excellent study, one of the first probably healthcare LCAs done, environmental impacts of a hysterectomy. So what was the question? Their question was, what is the environmental impact of hysterectomy? A very precise question. So that's what you need to have. And what's a functional unit? One hysterectomy. So you need to have that. For example, if you're taking an OR, and then, 1 day in the OR, for example. So that would be a functional unit. And that's very important because you're going to build all of your processes based on that functional unit. And then you need to define your boundaries, which is very, very important because, again, lack of data in healthcare, and look at how they built their boundaries, what they're going to look at. And everything that's beyond these boundaries, they're not looking at it. And then they're telling you this is not what we're looking at. Okay, and that's very important. It keeps changing probably while you're doing the process because of lack of data. And then the next is life cycle inventory or data collection. In my opinion, this is the hardest step, and there are 2 steps to it. One is you create audits in your unit, for example, like we accounted everything from patient travel to the waste audits. And this requires literally sorting through waste. And you won't imagine the number of gloves I've seen in trash cans. And by the way, I'm called the trash lady of my endoscopy unit. And then you itemize all of these, make spreadsheets, every equipment, every instrument that goes into your process needs to be accounted for. And then you got to keep track of all these spreadsheets. So these were all our audit spreadsheets. And if you look, there's so many instruments, and just every process is built into it. And spreadsheets are your best friend. They were not mine. I'm trying to learn those. Now, if you look, there are many instruments on those. Now, the next process would be to create your life cycle of each of these instruments. For example, so this is how we built our tables. For example, you take one clip. Where is it being manufactured? What is the material composition? What plastic is being used, or what metal is being used? Now, that is very, very hard in healthcare LCA because that is not disclosed. So what are your data sources? It's very, very hard. Like I said, if you can contact companies and if they can disclose it to you, that's great. We had to actually sign an NDA to a company, and we couldn't even disclose what they said because there was an NDA. And we collaborated with a Spanish group, actually used engineers and broke down all the instruments and told us what the components and what different metals were, and different types of plastics, etc. And then, and then you build, or you can use LCI databases. It's the LCI websites where I can give you resources for that. And those have some databases built into them that can help you with some of these materials. Or you can look for reliable sources like government websites. And then after you built all of these, and so now you're done with the hardest part. Now is the fun part where you can play with these softwares. You input all of these things into the softwares, and then it spits out your impact categories, like what is the environmental impact of a particular thing. For example, here I think we did a syringe, and that's what is the environmental impact of it in a tabular form, and this is the graphical form. And then afterwards, you kind of add up everything. And I have not even accounted for HVAC and facility things in this, but that's basically all of these things go into the carbon footprint of any product. My tips would be, you cannot do this alone. You need a big team to do this. You need an LCA expert to guide you through this. And like we said, cost is a big factor. These things are very, very expensive. Questions?